Hi folks, round 2, section 7.2. If you watch section 7.1, we left off on the graph for number 4, and we already did the equation for number 5. So if you want to know where this equation came from, it's the original problem, which is above. Please consult the previous video. So as far as graphing inverse equations, it's as simple as this. I have a y-intercept of 8 here on my original graph, so 1, 2, 3, 4, 5, 6, 7, 8. I got a slope of 2/3. I'd like to go up 2/3, but I can't do it. So 1, 2, 1, 2, 3. Keep in mind, positive slopes always tilt to the right. So we got that guy. So if you watched the previous video, one of the things we mentioned was that if you are going to do multiple graphs on one grid, you can look over at example number 4, we need to label both of them. So it wouldn't hurt just to do that right now. It's the original graph, which is y. And take a look over here. So that notation is for an inverse graph. So my second graph I'm going to do, I better make sure that I have an inverse notation with it. So if you watched the previous video, we showed you how to come up with an equation. Well, we don't even need the equation for this. All I have to do is say this. If I know that this set of coordinates right up here is 0, 8, then I can flip my coordinates to get an inverse graph. So I'll go ahead and graph that guy. If I know this set of coordinates right here is negative 1, 2, 3, 6, then I'm going to flip it and make it 6, negative 3. Sorry about that. That was kind of terrible. So 1, 2, 3, 4, 5, 6, negative 3. And if I know that this set of coordinates clear over here is negative 1, 2, 3, 4, 5, 6, negative 6, 4, I'm going to go 4, negative 6. And I'm going to flip those guys around. And it's that easy. If you're good at graphing y equals mx plus b lines, which you should be by now, then can you write down a set of coordinates and flip them? And if you can, then you can graph an inverse graph. So let's get this guy. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, let me connect those up. Oops, wrong feature. There we go. I got it. So it's that easy. Put some arrows on the end here. And let's change colors just for kicks to make this point. So if you watched the last video, we said that this line going right up through here is called the axis of symmetry for all inverse graphs. So no matter what, you are supposed to be drawing me two lines that are symmetrical over this. So again, if you were to flip the blue line and the green line, they would land right on top of one another. A little extra information, the equation of this line, this 45 degrees, so it goes up at a 45-degree angle through the origin, is y equals x. So y equals x, literally the line of symmetry for inverse graphs, always. All right, so if you watched the previous video, we didn't actually do the equations for the other two graphs. So we're going to do the equations first. So if you didn't watch that, you're going to get to see how to do an equation anyway. And if you did watch it, I apologize for repeating myself. All right, for starters, g of x, f of x, h of x, all the function notations means the same thing as y equals. So all we have to do to find an inverse, or inverse equation, is to flip the x and the y. So I'm going to put the x where the y was. I'm going to put the y where the x was. And then you got to get y by itself, no choice. So let's see here. I'm going to start with that 3. I'm going to get rid of that 3. 2y minus 4. How do I get the 4 to the other side? I add it. And how do you get rid of the 2? You divide. So I got 3x plus 4 over 2 equals y. So again, we did say that you could divvy that up And another way of writing that, and that would be acceptable as long as you put the little -1 inverse notation on it. I could also say, hey, my 3x is getting divided by 2, and my 4 is getting divided by 2. But if you are going to take the time to split these guys up, then you got to reduce them. Okay, and we got it. So this guy right here, inverse equation. All right, now I'm going to go ahead and hit number 7 here while I am on this portion of the notes, and then we'll go ahead and do some graphs. This sounds silly, and it's one of those deals where like the easiest problem ends up being the one that gets missed the most. So if you're supposed to make the y into an x, well, that's kind of hard to do if there's no y. But you're also supposed to make the x into a y. So at the very least, I can do that. And this is going to sound too good to be true, but if I do that, the y is already by itself. All I got to do is stick a little -1 notation on there, and I'm done. All right, so don't overthink on that one. I think that makes sense. If x equals something is the original problem, then y equals something is the inverse of it. All right, well, let's graph these two. And I've already put those two equations down here. Well, I had them. Oh, there they are. Okay, so on number 6, though, this is kind of cool. You have the original problem right here, which would be hard to graph. But then we took the time to find the inverse graph. So, hey, does it matter which one we graph first? No, it doesn't. So I can go ahead and graph the inverse guy first, because I don't know about you, but I don't want to graph this guy right here. It's kind of crazy, that big old fraction. But I can graph the one on the right fairly easy. Y-intercept of 2, up 3 over 2, maybe down 3 over 2. Let's draw a line in there. Well, let's try that again. All right, third time's a charm. Hey, there we go. All right, but make sure to label that one. That was my inverse graph, so I'm going to put a y-1 on that. So again, all I have to do is flip-flop the coordinates, and I got myself an inverse. So original set of coordinates I graphed right here, that's 0, 2. I'm going to graph 2, 0 instead. This set of coordinates up here is 2, 5. I'm going to flip it, graph 5, 2 instead. This guy down here is -2, -1. Flip them around, I get -1, -2. Right there. And I'm going to go ahead and draw this without the line feature because I'm worried about losing time. Label him Y. There you go. Okay, now the axis of symmetry line is optional. You don't actually have to draw that, but it is helpful because you can tell that if you've done it correctly or not. And those two guys do look symmetrical to me. All right, number 7. Should be the easiest one, most missed. So here's the original problem. Way back when we were talking about linear equations, you're supposed to know if it's only an x, it's going to make a vertical line. And I would hope it makes sense to put a dot at -3, because it says x equals -3. So you could also label the line literally with the equation. So I'll do that on this occasion. So the inverse, okay, well, don't think too hard. We don't switch signs on these. So it's still got to be -3. But this time I put it on the y because the inverse equation was this guy. So what do you think? If you had a horizontal line, if you had a vertical line to start with, well, what's going to be an inverse of that? It's going to be a horizontal line. And there you go. All right, if you watched part 1 video, I lied to you and I said the third type of problem, which is the proof problems, would be in part 2 video. But I'm going to run out of time, so you're going to have to go to part 3 video to check that out. As always, thanks for watching.